In today's society, automobiles are an indispensable part of our lives, and among them are the next-generation automobiles. These next-generation vehicles are vehicles that emit less air pollution-causing substances, and they include electric, hybrid, and plug-in hybrid vehicles. Currently, there is a worldwide effort to promote these next-generation vehicles for a sustainable society. In Japan, for example, next-generation vehicles began to gain importance after the G8 Hokkaido Summit held in 2008 at Toya Lake. The Japanese government set a goal of increasing the share of next-generation vehicles in new car sales to 50 to 70% by around fiscal year 2030. In this video, we will discuss electric vehicles, known as EVs, and consider why they are needed. Chapter 2: Automotive History. The power source for automobiles has evolved over a long period of time. Various power sources were tried at first, but the current mainstream power is by internal combustion engines, such as gasoline and diesel engines. In recent years, however, new power sources, such as electric vehicles and fuel cell vehicles, have been commercialized to address environmental issues. This section provides a history of automotive power sources and an overview of each. 1. The steam engine. The first source of power for automobiles was the steam engine. In 1769, French inventor Joseph Cugnot invented the steam engine, which had been used mainly for the railroad. In 1807, the British company Trivik built the first practical steam-powered car. This three-wheeled steam-powered vehicle was capable of traveling at 13 km per hour. Steam engines had the advantage of being able to produce a relatively large energy output, but they also had many problems, such as limited fuel availability due to boiling point restrictions, and long preparation and startup times. In addition, boilers were slow to heat and required frequent water supply. Therefore, they were mainly used for short-distance transportation. Steam-powered cars were developed in the US in the 1860s and were popular for a time, but production ended around the 1920s with the commercialization of gasoline engines. 2. The gasoline engine. The gasoline engine was invented by the Germans Gottlieb Daimler and Wilhelm Maybach in 1885. The gasoline engine is an internal combustion engine that sucks in an air-fuel mixture, compresses it, and ignites it to produce power. The gasoline engine was ideal for powering automobiles because of its small size, lightweight, and high output. In 1886, Carl Benz from Germany built a three-wheeled automobile with this new engine, the Benz patented Motorwagen, which became the world's first modern automobile. Later, the American Henry Ford established an automobile company in 1896, and the mass production of gasoline engine automobiles began in earnest. Initially, they were only one-cylinder, but with the introduction of multi-cylinder and electric starting systems, the gasoline-powered automobile gradually became more and more practical. In our contemporary society, gasoline engines are the primary power source for passenger cars because they are lightweight, compact, easy to handle, and offer good power output and response. 3. The diesel engine. The diesel engine is a compression-ignition internal combustion engine invented by German Rudolf Diesel in 1897. Air is highly compressed and heated, and fuel is injected and ignited at that high temperature. A major advantage of diesel engines is that they have higher thermal efficiency and better fuel economy than gasoline engines. On the other hand, however, emissions such as nitrogen oxides, or NOx, have become a problem. Diesel passenger cars first appeared in the 1930s, but at that time they were mainly used in commercial vehicles, ships, and generators because of their greater vibration and noise compared to gasoline engines. However, with subsequent technological advances, quietness and vibration have been improved, along with emission controls, and diesel engines are now widely used in passenger cars. Diesel engines, such as inline four-cylinder and V6 configurations, are common and are the main source of power for medium and large vehicles, in particular due to their high fuel efficiency. 4. The electric vehicle. It is often not known that electric vehicles were developed earlier than gasoline engines, starting in the 1830s, but were superseded by gasoline engines because of their smaller storage battery capacity and shorter range. Since the 1990s, however, the dramatic improvement in performance of lithium-ion batteries and a growing interest in environmental issues have stimulated the renewed development of electric vehicles. Lithium-ion batteries have a higher energy density than conventional lead-acid batteries, and this has greatly increased the cruising range of EVs. In recent years, electric vehicles that can travel more than 300 kilometers on a single charge have been commercialized, and many models have been introduced by major manufacturers. Chapter 3. Why are EVs in the spotlight? 1. Performance. The engine in a gasoline-powered vehicle generates energy using a physical piston and a rotational motion, which leads to noise and body vibration. On the other hand, EVs do not have such engines, resulting in less noise and vibration. This is a positive advantage for comfort and noise reduction. In addition, EVs are described as smooth running, which is related to the process from stepping on the accelerator pedal to create acceleration. In a gasoline-powered car, the engine speed increases when the pedal is pressed, and when the appropriate RPM is reached, the car can accelerate significantly. In an EV, the signal is transmitted to the motor when the pedal is pressed, and the car can accelerate significantly from the beginning. 2. Environmental burden. EVs are considered to have lower carbon dioxide emissions than gasoline-powered vehicles. In fact, comparing the carbon dioxide emissions of the two types of vehicles, EVs emit about half as much carbon dioxide when driven compared to a gasoline-powered vehicle. On the other hand, however, the manufacturing process for lithium-ion batteries, the battery part of EVs, requires heating to more than 1,000 degrees Celsius, and it involves a continuous operation of a large drying furnace, which increases greenhouse gas emissions by about 70% compared to gasoline vehicles during EV production. The flow of a vehicle from the production process to disposal is called its life cycle, and the amount of greenhouse gases emitted during its life cycle varies depending on the distance traveled and other factors. Gasoline-powered vehicles emit fewer greenhouse gases during the production process, but more during driving. Conversely, EV vehicles emit more greenhouse gases during the production process, but less during its operation. In other words, looking at the entire life cycle in this way, the longer the cruising range, the more environmentally friendly the EV is than a gasoline-powered vehicle. Chapter 4. Initiatives. The global initiatives on EVs can be broadly divided into 4 categories: country-led, company-led, both country and company-led, with equal influence from both, and indifferent. A. Country-led, China and Norway. The Chinese government has set a goal of increasing the ratio of new energy vehicles, such as electric vehicles, to 45% of all new vehicle sales by 2027, with the aim of creating an automobile powerhouse. Originally, the Chinese government set a goal of increasing the ratio of new energy vehicles to 50% by 2020 to 2035. The plan was to raise the ratio in stages to 20% in 25 years and 40% in 30 years. However, the spread of EVs has been greater than expected, so the government revised the goal. The current target is 45% of all vehicle sales by 2027. The Chinese government is aiming to transform itself from an automobile superpower with the world's largest sales volume into an automobile powerhouse that leads the global market by leveraging the shift to EV vehicles. EV vehicles were positioned as a priority area in the China Manufacturing 2025 policy, a high-tech industry development policy announced in 2003. The policy has been supported through preferential taxation and subsidies. The Chinese government's support measures have been successful, with Tesla Inc. of the US being lured to build a factory in Shanghai to expand production, and BYD, a major Chinese automaker, also increasing production and sales. Norway is providing a multifaceted support to encourage ownership and the use of electric vehicles, which include tax exemptions, tax breaks for EV purchases, improved charging infrastructure, free parking in the city, and preferential treatment on toll roads and ferries. As one example, the 25% value-added tax, known as VAT, on gasoline and diesel vehicles will be waived for EV purchases. In addition, EVs will receive preferential treatment in the use of public services, such as reduced fees for the use of highways, parking spaces, and car ferries, with exemptions for EVs to drive in bus lanes, and taxes will be reduced for company cars. Furthermore, EVs, which do not emit emissions, do not need to pay the additional fees that gasoline and diesel vehicles are subject to, depending on the amount of emissions from the vehicle. As of the first quarter of 2021, there were 19,119 public charging facilities in Norway, with 147 passenger cars registered per public charging facility. B. Corporate initiative. Tesla, the United States. Tesla's supercharger network of quick chargers is not only promoting long-distance travel for its customers, but is also open to other automakers in order to promote the purchase and use of EVs. Tesla's NACS charging standard is also being adopted by other automakers and EV charging companies. In the summer of 2011, Tesla agreed to make EVs for Nissan, Ford, Mercedes-Benz, General Motors, and Livian Automotive, an emerging US EV manufacturer. All vehicles would be NACS compatible. At the same time, they have partnered with ChargePoint, which operates EV charging networks in the United States, and with Electrify America on the installation of NACS chargers, and have granted a license to Bolex in the UK to manufacture Tesla's charging infrastructure. In August 2021, the US set a goal of raising the percentage of EVs and other vehicles as a share of new car sales to 50% by 2030. Furthermore, in April 2023, the US Environmental Protection Agency, the EPA, announced the combined pollutant emission standards for model year 2027 and later light-duty and medium-duty vehicles. It is hoped that this regulation would regulate emission standards for greenhouse gases and air pollutants, resulting in a major boost to the spread of EVs and environmentally friendly carbon-neutral vehicles. C. Both sides with equal influence, the EU. According to the European Automobile Manufacturers Association, ACEA, 27 countries in the European Union, EU, sold 7.94 million new vehicles in the January-September period of 2023, which was up 16.9% from the same period last year. The increased sales in new vehicles was mainly due to the easing of supply constraints on semiconductors. Therefore, the market itself continues to recover. Based on this performance, new vehicle sales in 2023 are expected to exceed 10 million units for the first time in 4 years. Gasoline-powered vehicles, which saw 2.88 million units sold, were the top-selling new vehicles in the same period, accounting for 36.2% of the total. Hybrid vehicles, HVs, came next at 25.2%, followed by diesel vehicles, 14.1%, with EVs fourth with a 14% share of new vehicles sold. New vehicle registrations for EVs themselves totaled 11 million units, up 55.2% from the same period last year. In September, VW also sold a total of 2.5 million vehicles from 2 of its plants in the eastern German state of Saxony. The company announced that it would reduce production of EVs at its 2 plants for about 2 weeks in October. Moreover, the plant in Zwickau is proceeding with the liquidation of fixed-term employees, citing weak demand as the reason. Simply, the EV production structure has been revised considerably. Why then has the demand for EVs in Europe weakened less than expected by all vehicle manufacturers? The biggest reason is that government incentives have been cut. Governments not only in Germany but also in other EU countries have been provided with subsidies and incentives, and the companies were also offering subsidies and tax incentives for the purchase of EVs and PHVs. However, these incentives were phased out in response to the financial restructuring trend, which put pressure on demand. On the other hand, there is still a lack of charging points infrastructure necessary for EVs to spread. According to the German Federal Network Agency, the number of charging points in Germany was at August 1st, 101,421 units. Even though the number of fast charging points increased by 13,302 units in the first half of this year, the number of fast charging points remains at 19,859, a level that is insufficient for the further spread of EVs. D. Indifference, Japan. One of the reasons why electric vehicles are not widely used in Japan is the lack of EV charging infrastructure, which is seen as a critical problem. Just as gasoline vehicles require refueling in order to run, electric vehicles require recharging. There are two types of charging methods for EVs: normal charging and fast or quick charging. Quick chargers are installed at highway service areas, shopping malls, and convenience stores. However, the cost of installing and maintaining quick chargers is high, and the availability of charging infrastructure varies from area to area. Therefore, in order for EVs to spread in Japan, the EV charging infrastructure needs to be increased. The high price of electric vehicles, compared to gasoline and hybrid vehicles, is another reason why they are not widely used in Japan. For example, the Nissan Leaf, 40 kWh model, is one of the most affordable electric vehicles, with its price ranging from 3.7 million to 4.2 million yen. On the other hand, the same Nissan Leaf 40 kWh model price of gasoline and hybrid vehicles ranges from 2.15 to 2.85 million yen. Quite simply, electric vehicles have higher vehicle prices than gasoline and hybrid vehicles, which is the reason why they are not widely used in Japan. Long charging time for electric vehicles is also a constraint. Charging time for electric vehicles is generally 5 hours or more at minimum, and around 10 hours at maximum when charging at home. When charging at EV charging spots, it can still take about the same amount of time as when charging at home, although it varies slightly depending on the charging output. For example, if an electric vehicle with a battery capacity of 50 kilowatt-hours to be fully recharged from a battery with 20% remaining capacity would be 50 kilowatt x 80%, 40 kilowatt-hours amount of electricity required. So it takes 40 kilowatt-hours 6 equals 6 hours to fully recharge the battery at 6 kilowatts output. Therefore, the charging time for electric vehicles is lengthy, which is the reason why they are not widely used in Japan. Furthermore, currently, electric vehicles have a shorter cruising range than gasoline or hybrid vehicles, which is yet another reason why they are not widely used in Japan. The cruising range of a vehicle refers to the distance a vehicle can travel on a single refueling. In the case of an electric vehicle, this refers to the distance that can be traveled on a single charge at optimal speed and energy use. There is no problem when using the electric vehicle for daily driving, such as commuting or shopping. However, many people feel uneasy when driving long distances, such as on a trip, because charging infrastructure facilities are not widely available. Adding to the list of reasons why EVs are not widely used in Japan is that many people live in apartments, and there are few apartment complexes with EV charging facilities. When purchasing an EV, the ability to charge the battery at home has a major impact. Japan is one of the countries with a relatively large number of collective housing. This factor contributes to the slow uptake of EV data compared to other countries around the world. In Japan, electric vehicles are often not considered zero-emission vehicles. Electric vehicles are called zero-emission vehicles because they do not emit CO2, since they are powered and charged by renewable energy sources such as solar power and nuclear power. However, since Japan lives mainly on thermal power generation, a large amount of CO2 is emitted at power plants when producing the electricity needed for electric vehicles. Although possibly a pedantic splitting straws debate, the energy generation cycle needs to be considered if the focus is on CO2 emissions and climate change. Chapter 5: Why we need EVs. One of the main reasons EVs are deemed necessary is to solve environmental problems. EVs are widely recognized as environmentally friendly next-generation vehicles that emit less carbon dioxide during operation, and they can contribute to achieving a carbon-neutral society. However, EVs emit significant amounts of carbon dioxide during their production process. While countries need to promote EV adoption domestically to achieve carbon neutrality, they must simultaneously minimize domestic EV manufacturing. This situation forces countries to import EVs, with the EV manufacturing countries, which may become those that continue to emit carbon dioxide without adhering to international environmental initiatives. This dynamic suggests that the necessity for EVs might not be about solving global environmental problems, but rather about enabling EV-using countries to achieve carbon neutrality, while EV manufacturing countries become economically prosperous. Nevertheless, EVs have clear advantages, including environmental benefits, reduced noise and reduced vibration. While challenges remain, such as environmental impact during manufacturing and infrastructure development, there is no doubt that EV adoption is essential for achieving a sustainable society in the long term. Government policies and technological innovations being pursued by various countries and companies will be crucial factors in supporting the future widespread adoption of EVs.